Hi students, welcome back to the next video of our series. In this video, we study about what is a pseudo force. And we'll learn some problems and solve some problems related to pseudo force so that we can apply this concept of pseudo force, which is sometimes confusing to students. So before we learn about pseudo force, we need to understand about frame of reference. So what is frame of reference? Frame of reference is a point or place where you observe the motion of any object or particle. Means what do you do? From where you are observing the things, that is called as frame of reference. Suppose when you're sitting in a train and you're observing the trees moving, and for you who is sitting in the train, anything that is attached to you, if you're observing that the motion you're observing of trees and sideway footpath and any other thing around the train, you will be that frame of reference from where everything is getting observed or the motions are recorded. Suppose when you're riding on a bike, so if you're observing the motion of all other objects, if the person, so anything attached to your bike, from where you can observe all the things, is called as frame of reference. What do the frame of reference contain? It contains a clock. Clock means why? Because with time the position of other objects are changing. So it contains a clock attached to it and a coordinate axis attached to it, so that we can point out the change of positions of different objects with respect to that frame of reference. So this is the definition and understanding of frame of reference we should have. Then what kind of frame of reference will be there? There are two kinds of frame of reference. One is inertial frame of reference and other is non-inertial frame of reference. What is inertial frame of reference? What is non-inertial frame of reference? Inertial frame of reference is the reference frame which is at rest or in uniform motion, but in reality, will you be able to find out any inertial frame of reference in this world? You might think, and now I'm sitting on the bench, on the chair, and I'm explaining you. You might think that I am an inertial frame of reference. But if you go to moon and observe me, I'll be moving, I'll be accelerating. So I am not an inertial frame of reference. But in this way, there's no inertial frame of reference in this world. But for our practical purposes, for at least solving Newtonian mechanics, that all Newton's laws of motion and all we are studying here, Newtonian mechanics, we consider Earth to be an inertial frame of reference. And anything with respect to Earth, and we observe the things. So what is inertial frame of reference for our practical purposes? If anything, any frame of reference is at rest or in uniform motion with respect to Earth, first we considered Earth as inertial frame of reference for our Newtonian mechanics. Then any frame of reference which is at rest or in uniform motion with respect to Earth is considered as inertial frame of reference. So what is non-inertial frame of reference? Any reference frame which is accelerating with respect to Earth is called as non-inertial frame of reference. There are two frames of reference. One is inertial and other is non-inertial. Inertial is there's no inertial frame of reference in reality, but still Earth we consider to be an inertial frame, and anything, any object or any reference frame which is at rest or in uniform motion with respect to Earth is considered as an inertial frame of reference, and anything that is accelerating with respect to Earth is considered as non-inertial frame of reference. So let us go to the next part of our concept. You might ask me, you started with pseudo force, but you haven't taught anything about pseudo force, and you taught us inertial frame of reference and non-inertial frame of reference. So why they are important for teaching pseudo force? That's all right. We cannot apply Newton's laws in non-inertial frame of reference. Why? Let me see. Suppose there's a man standing here. There's a car here on the ground. So here another man is standing here. So let us consider this is me. And this is you. Okay. So now, so let us, both of us, I'll do an assignment here. What is that assignment? I need to draw free body diagrams for this man of mass m from both Ganpati, that is me, and student point of view. So here the student is sitting in this car, and this car is accelerating with a acceleration in the forward direction. So you tell me, first point, what is the free body diagram of this man according to me? What is this free body diagram? So there is a gravity acting on the man, which is equal to mg, and there is this man is at rest, okay, with us here ground, on the ground. He's not moving, on the ground. He's at the same coordinate position. Then there will be a normal reaction due to earth, ground on this man, which is m. Is there any other force that I can see here? No. So what can I do here? The man is at rest according to me. N minus mg is equal to 0. So n is equal to mg. Okay, my forces are balanced and there is no other force. The net force is 0. So acceleration is 0. Then this is over from my point of view. From the student point of view, again, the free body diagram is like this. The force is mg, and there is a normal reaction, and there is no vertical motion. So n minus mg is equal to 0. So n is equal to mg, another thing. But you carefully observe here. But the net, are there any other forces according to student on this man? Absolutely no. But is this man moving or at rest with respect to the person sitting, that is student, in this car? If you have guessed it, the man is going backwards with an acceleration a from the observer who is sitting in the car. This looks awkward. There are no other forces which are acting on the man who are in the horizontal direction, but still there's an acceleration. to this man, is he actually moving with respect to the ground? No. But according to the student who is sitting in the car, he will see the man is going backwards away from him with an acceleration a, but there is no force acting on it. So here you might ask Newton, Array Newton Saab, you told F net unbalanced force, external unbalanced force, is equal to mass into acceleration. Here in this case, the man has an acceleration a, that means there is ma part in it, but net external unbalanced force is what? 0. It's a big 0. Here our Newton's law, second law, is not valid. We are unable to apply that law. So Newton law, to solve this problem, to make Newton's law valid, a new concept. It's in reality is at rest, but according to the situation given here, he is not at rest. So to make our Newton's law valid in this situation also, there is something called, in this unrealistic situation, there's unrealistic force, that is pseudo force, which should be taken into consideration to make this problem valid and Newton's law can be applied. How? In this kind of situations, we should take a pseudo force, and that pseudo force, it's a force, so it should have a magnitude and it should have direction, and its magnitude equal to that mass of the observed object. Here the mass of the man is m into acceleration of frame of reference. Here the car is accelerating at acceleration a, so we can say that should be mass into a. So what is the direction of it? And that one is magnitude, another is direction. What is the direction of it? The direction of it is opposite to the acceleration of frame of reference. The car is accelerating in the right side direction, so there will be a pseudo force in the left side direction of the given question. So let us see here in this question, pseudo force should be taken to make this problem valid. What is the direction, magnitude of pseudo force? Yep, pseudo force is equal to mass into acceleration of the car here. What is the direction? Opposite to the acceleration of the car. Acceleration of car is in positive direction, positive x direction. The acceleration of the frame of reference will be in the negative x direction. So this is the direction of the pseudo force. You see here, if you apply Newton's law here, there is an unbalanced force now has come due to the pseudo force. That pseudo force is what? Mass into acceleration of the car, that is equal to net unbalanced force is equal to mass into acceleration, cancel. A is equal to acceleration of the car. So now the acceleration of the man is actually what? Acceleration of the car in the opposite direction. So our Newton law has become valid. Let us solve some very trivial problem that you already solved in the previous video to make our point more clear. So let us see the situation. An elevator problem. A block is kept in the elevator and the elevator moving upwards with an acceleration a. So now the question is, what is the normal reaction on the block? This we have solved already in one of our previous videos. How did you solve it? By standing here. So you did it. Free body diagram on this. Mg downwards, normal upwards, and there's no other force in it. N minus mg is equal to mass into acceleration of the block. From the ground, the acceleration of the block is what? This acceleration of the elevator. The block is moving upwards with an acceleration of elevator, that is ma. So n is equal to m into g plus a. This is the answer we need to get. But for the same situation, I'll solve the problem by using pseudo force. You see, if I go and sit in this elevator, suppose this is a man, some A man, and this is a B man, and this is B. You assume I am B. So according to the B, the block is at rest, isn't it? Okay, let us see. If B is in the elevator and the B is also moving upwards with an acceleration A. If B is moving upwards with an acceleration A, that means B is non-inertial frame of reference. So whenever the point of non-inertial frame of reference comes to picture, we should consider what? Pseudo force. How that pseudo force will be there? So first I'll draw the free body diagram. There is a mg force due to gravity. There is a normal reaction due to surface of the elevator, and there is a pseudo force because the observer is non-inertial frame of reference. So what will be the direction of that pseudo force? The direction of the pseudo force will be opposite to the acceleration of the frame of reference. That B man is accelerating in the upward direction, so the pseudo force will be in the opposite direction to that acceleration, that is FPS in the downward direction. So now according to that B man, what is the acceleration of this block? The acceleration of the block is 0. Why? Because for a man sitting in the elevator, the block is at rest. So if the block is at rest, net force should be what? 0. So I'll make this net force is 0 here. Net force is what? 0. That means upward force is equal to downward force, right side force is equal to left side force. So N is equal to FPS plus mg. What is FPS pseudo force? What is the magnitude of pseudo force? Mass into acceleration of the frame of reference. Here acceleration of B is A, that is ma plus mg. Mass onto A plus g. You got the same answer as here from the ground. But sometimes by taking pseudo force into consideration, the problems become a bit more simpler. So that's why we take pseudo force into consideration when the reference frame is accelerating. So let us see some other situations where pseudo force can be applied and solve the problem, and the problem can be solved. Suppose there's a question. There's a car here. There is a pendulum here, and this car is accelerating at A in the forward direction. So we know if this is constant acceleration, the pendulum will stay in this position at an angle theta with the vertical. So now the question is, what is that angle? What is that angle? Theta. So see how I'll be able to solve this problem by using pseudo force in an easy manner. So if a person sitting here, if I go and sit in a car, for me the ball seems to be at rest, isn't it? Just the ball hangs in a horizontal position like this. So let me draw the free body diagram to this ball. If I draw the free body diagram to this ball, there is an mg force. Consider this mass of the ball. Bob is mg force. There is a tension due to string T. Is it over? Is there any other force? Yes, you're guessing it right, because here the observer is sitting in that car. According to him, according to us, actually he is non-inertial frame of reference because he is in the car and the car is going with an acceleration A. That means he is also accelerating with an acceleration A with respect to ground. That means he is non-inertial frame of reference. If he is non-inertial frame of reference, there should be a consideration of pseudo force. What is the direction of that pseudo force? Opposite to the acceleration of the frame of reference. So car is accelerating in right side direction, the acceleration will be in the opposite direction, FPS. So this is theta. According to the man who is sitting in the car, the bob should be at rest. If it is at rest, means the net force on it should become zero. So net force on it should become zero means, so I will try to resolve this tension into two components. One is T cos theta. This resolution I have taught you already. And the other one is this is theta adjacent side, T cos theta, and opposite side, T sin theta. So now you see, for the bob to be at rest, net force should become zero. That means vertical forces should get balanced and horizontal forces should also get balanced. FPS should be equal to T sin theta, and mg is equal to T cos theta. So if I divide both of them, tan theta is equal to FPS by mg. FPS is what? What is the magnitude of pseudo force? Mass into acceleration of the frame of reference. Here the acceleration is A of the car, that is divided by mg. FPS by mg. Cancel. That is theta is equal to tan inverse of A by G. If sometimes acceleration theta is given, if acceleration is asked, A is equal to G tan theta. If theta is given and acceleration is asked, that acceleration will become G tan theta. This is one question I solved just by using pseudo force, so that you can apply this kind of pseudo force whenever there is observation from non-initial frame of reference. So let us go to another question. Let us solve another question on this. Let us solve another question on pseudo force. There is an inclined plane with an angle of inclination theta, and there's a block of mass m kept on this. So now, what is this is smooth floor, smooth inclined plane. What is the acceleration with which the inclined plane should have, so that the block, carefully listen to this question, block is at rest with respect to inclined plane? This is a wonderful question. You carefully observe this question. So the question is asked, actually what should happen? The block, if it is inclined plane is fixed, the block should accelerate with G sin theta acceleration, as we have solved in our previous videos, along the inclined plane. But here he is saying the block should be at rest with respect to the inclined plane. The block should be at rest with respect to inclined plane. So if I go and sit here, for me, if the inclined plane is accelerating, and for me, if I am an accelerating frame of reference, I become a non-initial frame of reference. So there should be a consideration of pseudo force. After pseudo force coming into air, the block should be at rest. For me, the block is at rest. So I'm going and sitting here and trying to solve the problem. So what is the free body diagram of this block? There is mg force. I'll draw the diagram again. There is mg force downwards and normal reaction which is perpendicular to the surface n. And what should happen to make the block at rest? I assume the inclined plane should accelerate in this direction A. So if it accelerates in this direction, there will be a pseudo force which will act in this direction, FPS. So if this is theta, this will become theta. And now you see this. Normal will be perpendicular to the surface. This is theta, this will become 90 minus theta, and this will become theta again. This will become 90 minus theta, and this will become theta again, and this will become theta. Vertically opposite angles. So this entire force should become 0. Normal, mg and fps, net force should become 0, so that the block is at rest according to the man sitting here. So I am resolving this n into n cos theta and vertical direction, horizontal direction, n sin theta. So if I resolve it into two components, n sin theta is equal to fps and n cos theta should be equal to mg, so that the net force on the block is 0. Tan theta is equal to fps by mg. What is pseudo force? Mass of the block into acceleration of the frame of reference, that is a here, divided by mg. Cancel. That implies a is equal to g tan theta. If the inclined plane is going with an acceleration a is equal to g tan theta, then the block will be at rest with respect to the inclined plane. Block will not slide. And there might be sometimes another question asked on this. What is the force that should be applied on the inclined plane plus block? What should be the force? It should go with an acceleration g tan theta. What should be the force? That force should be equal to m plus m. Two blocks, both the blocks should be going horizontally with an acceleration a, that is m plus m into g tan theta. If you angles, you carefully observe. Some students might be confused with the angles that I have written here. Just try to use your basic geometry applications and get these angles. If this is theta, this will become theta, because they both are horizontal and this is an inclined plane with the same horizontal. So corresponding angles, this theta, if this is theta, this will be theta, and this is 90. This entire angle is 90 because normal is perpendicular to the inclined plane. So this will become 90 minus theta. So here this is 90 minus theta because this is 90 here, and this will become theta. If this is theta, this is a line, vertical line, vertically opposite angles. If this is theta, this will become theta. So if you know this basic geometry application, this problem can be easily solved. Let us go to next question. Find the mass m. Find the mass m of the hanging block in the figure. Find the mass m of the hanging block in the figure, which will prevent the smaller block from slipping over the triangular block. All the surfaces are frictionless and the strings and the pulleys are light. It should not slip. The smaller block should not slip over the triangular block. That means the same concept that we have seen in the previous question. That this block, for this block to not slip with respect to this wedge, this wedge should go with an acceleration g tan theta that we have studied from the previous question. So this wedge should go with the acceleration g tan theta. This entire system should have a force. That force should be equal to m plus, that is here m dash plus m into g tan theta. If this force is applied in the right side direction, then there will be an acceleration g tan theta on this for the wedge, and the block will be at rest with respect to the wedge. Just a continuation to the previous question. So if this force should be m dash plus m g tan theta, what is providing this force to this wedge. That force should be provided in this question by the tension. If you cut it and pull it, the tension in this direction will provide the required force, that is m dash plus m into g tan theta, to the wedge. So if you draw the free body diagram here, on this block M, there will be mg downwards, there will be a tension upwards. On this entire system, m dash plus m system, only tension, and there will be a m plus m dash g, and there will be a normal reaction. But this is not required for our business here. Only the horizontal force, which gives the horizontal acceleration g tan theta, is required in this question. So what is providing that acceleration here? Tension. That means here the tension is the unbalanced force. This tension should be equal to m dash plus m into g tan theta. So this block is also going, if the stud is going horizontally with an acceleration g tan theta, this block will also go downward with an acceleration g tan theta. Now writing the equation for it, m dash plus m into tension is equal to m dash plus m into g tan theta. Then the next equation is mg minus t is equal to mass into acceleration, that is g tan theta. If we add both of them, tt will be cancelled. So mg will be equal to m dash, this is small block, topmost block is small block, so m dash plus m into g tan theta. So what do we want here? Question, what is the question asked? Find the mass m of the hanging block in the figure. So this m we need. I will make it as a subject. Mg minus mg is equal to m dash g tan theta plus mg tan theta plus mg tan theta. I am making this m subject. Mg into 1 minus tan theta is equal to m dash plus m into g tan theta. If we divide this, cancel this g and g, that m is equal to m dash plus m into tan theta divided by 1 minus tan theta. So if you divide this if you bring this tan theta in this denominator, so m dash plus m into divided by 1 by tan theta, that is cot theta, minus tan theta by tan theta, that is 1. So this is the mass that is required, so that that small mass m will not slide over the wedge. So like this, whenever there is an accelerating frame of reference, whenever our perception becomes simple, if we are sitting on the particular body or system, then if we are accelerating, there is a pseudo force that comes into picture, and the direction will be opposite to the direction of the acceleration of the frame of reference, and the magnitude will be mass of that observed object into acceleration of the frame of reference. And if you use these two fundamentals and solve the problems, and a circular motion is such a topic wherein you find the application of pseudo force and you can solve a number of problems using that pseudo force. So I hope the pseudo force concept is cleared for you. Thank you.